So tomorrow, open quiz on the imaginary numbers. Block day, regular quiz. Then we have Friday off. Okay. Right, we have block day on Wednesday. And then we're going to have our test next block day, next week. So today's lesson is actually the last one for the month. It's the last one for the chapter because we will take an open quiz tomorrow, a regular quiz on block day. Then we'll have a couple days to review because the beginning of chapter 2 was a little rough, so I want to go back. I feel like you guys are good on this section of chapter 2, these most recent sections, but the beginning on parabolas and negative b over 2a was a little rough, so we're going to go back over that, and we'll take the test on block day of next week. So today all we need to do is to wrap up the idea of superfoil. Some of you, sounds like you already did it on some of your homework, like you actually superfoiled all of those problems out when you didn't really need to, at least for last night. Tonight we will. So we learned it, but not with imaginary numbers. So yeah, the only different twist is that we're adding imaginary numbers. All right, so our example today, I'm going to ask you to use superfoil to create a polynomial. So use superfoil to create a polynomial with the following facts. I want it to be degree 3. I'd like it to have a lead coefficient. A lead coefficient of negative 4. And then zeros of 3 and 2 plus I. So those are the stats, okay? Those are the statistics, the specs, I guess, on that polynomial. So I'd like you to create, using superfoil, create a polynomial that meets all of those requirements. All right, how many factors will this polynomial start with? Okay, because it's degree 3, I'm going to start with 3 factors. And what should be in front of those 3 factors? Negative 4, because that's the lead coefficient. So you have 3 factors leading with negative 4, and then you have the zeros. So the zeros will be x minus 3. And then your second factor, your middle factor, still has to start with an x. And then it will be minus the next 0, which was 2 plus I. So it actually looks like it has 3 pieces. It has an x piece, and it has the 2, and then it has the I. So it looks like it's a 3-piece. It's a trinomial term. And then the last factor would be x minus 2 also, but then it's a minus I to create the conjugate, because they always come in sets of conjugate pairs when you're dealing with imaginary numbers. When you superfoil, you should always start with the most complicated first. So start with the imaginary first. And when you superfoil those two together, you take a trinomial superfoiled to another trinomial, so 3 terms times 3 terms. How many terms will you end up with altogether? 9. Okay, 3 times 3 is 9. So you're going to end up with 9 terms. So that's a good way to kind of keep track so that you aren't missing anything. So I'm going to focus just on, I'm not going to do my negative 4. I'm going to save that for later. I'm not going to do my x minus 3. I'm going to do superfoil first. So I'm going to take my x, and I'm going to distribute it 3 times. That will create my first set of 3. So that will give me x, x squared minus 2x minus ix. My next set of 3 is going to come from distributing the negative 2. So this negative 2 will create 3 more terms. So I've created my first set of 3. Now I'm going to create my second set of 3. So that'll be negative 2x plus 4 plus 2i. And that's the second group of 3. So now I have 6 terms altogether. And then finally I want to do the I at the end. So I'll track that in blue. So I'm going to take that I and I'm going to do it 3 times. So that will give me plus ix minus 2I and minus I squared at the end. And I have my last 3. So just if you ended up with like 8 terms instead of 9, that would at least, oh, I'm missing one. I should have come up with 9. Now, if you do the hard superfoil first, the complicated one, a whole bunch of those i's are all going to cancel out. And so it's going to really simplify down. So if you're looking back through over that, you notice that you've got a negative ix right there, which cancels with the positive ix. And then you have a 2I, which cancels with the negative 2I. So a whole bunch of those terms are going to all cancel out with each other. And so you're really only left with x squared minus 2x minus 2x plus 4 minus I squared is what you're left with. And we all know that that I squared at the end should get changed to what value? Negative 1. So if that changes to negative 1, then I'm going to have a minus negative 1, which would give me actually a plus 1. So this will simplify all the way down to x squared minus 4x plus 5. So it became a much simpler problem, even though it started out quite complex. So I went from 9 terms down to just 3. Now I'll look at what was still, I neglected in the front, so I still have my negative x, or negative 4 times x minus 3. Now I'm ready to superfoil that. And again, save the negative 4, save the lead term for the very end. It's the most simple thing to do, so save the simplest for last. So now you want to take your x and you want to distribute that. So now I'm going to have what's called a binomial times a trinomial. I have 2 terms times 3 terms, so I should end up with 6 altogether. So I'll have x now to the third minus 4x to the second plus 5x. That's my first set of 3. And then I'll take my negative 3 and I'll distribute that 3 times. So I'll have negative 3x squared plus 12x minus 15. And that's my second set of 3. I can look to combine like terms on that. There's only one x cubed term. Of the x squareds, when I combine them all, there are 7 altogether. And then I've got 5x and 12x, which gives me 17. And then negative 15 at the end. But I still had my negative 4 out in front. So that'll be the last thing, because it is the most simple thing to do. The last thing I'm going to do is distribute that negative 4. Yeah?
4 plus negative 1, 5.
And then finally, I'm just going to distribute my negative 4 all the way through. So I'm going to have negative 4x squared plus 28x minus, let's see, 4 times 17, what's that, 68? And then plus 60. Which question? Because there were several of them that had 2x. So like, which one? 29. Okay. So did you get all the way to the point where like you had everything else, the rad and everything right, just not the 2?
I had 2's, like everything else was 2's, not the x.
Okay.
Instead of 1's.
Yep. Okay, so 29. If anybody needs me to back up farther, I can, but sure. Okay. All right, need your calculator for 29 because we start with a polynomial. All right, polynomial for 29 is x to the 4th plus, ooh, that doesn't look like a good 4, does it? X to the 4th plus x, yeah, x to the 3rd plus 5x squared. Okay, so Quentin, you're graphing this for me while I'm talking and making a mess of what I'm writing. Okay, because we're going to look at a graph and we're going to get some zeros. All right, Quentin, best case scenario. How many times would your graph cross the x-axis? now without looking at it, best case scenario, how many times would your graph cross? Okay, it would cross 4. Now look at it.
2.
Okay, so we didn't have our ideal situation. Where are the other 2? Okay, so from the graph, you saw 2 that were real, which tells us that the other 2 have to be imaginary. All right, well, let's at least get started with the 2 real ones that you see. So what real ones are visible to you off the graph? -1 and 1. All right, what do we do with those 2 real ones that we have? Okay, did you try that?
Yeah, I got those. I just didn't.
Okay. All right, so you got the synthetic and it like all worked out to 0 and everything good. Okay, so let's just double check. So we have 1, 1, 5, -1, and -6. All right, so you're feeling like pretty good. You powered through -5, -6, 6, 0, turned out 0. Okay, great. And then you did it again with the 1. Okay. So 1, 1, 1, 6, 6, 0. Okay, and then you got stuck? Okay. Yeah, Luke.
Does it matter which one you do first?
Oh.
Okay, mine didn't work out.
Okay, they both should work out to 0, and no matter what order you did it in first, you should always end up with 1, 1, 6 as your results. Okay, what do I do with the 1, 1, 6?
You put x squared plus x plus 6.
Okay, so we're reattaching the variables. And then that's where you went sideways? You thought the quadratic formula didn't work out for you? Okay, so let's check what you had for your quadratic. Just kind of read it to me.
I didn't even know I was supposed to.
Okay, all right, so let's do our quadratic. All right, so put the x equals -b, plus or minus. Let's get all that in the right order. -1, square root of, okay, 1 quantity squared minus 4 times 1 times 6. All right, all over 2. So that gives me -1 plus or minus 1 minus 24. Okay, and the 1 minus 24 is -23. And as soon as I have the negative, I confirmed, yep, they're imaginary, which I knew they were going to be imaginary because the graph only showed me 2. So what I would suggest for you to do at this point is split it up and have -1 over 2 plus or minus, and then have I in front of your rad 23 and have that be over your own 2. So what we have now are my zeros. My zeros are 1, -1, -1/2 plus I rad 23 over 2, and -1/2 minus I rad 23 over 2. Each 0 will be put into a factor. Okay, so what will the first factor be? And then we'll finally get to answer Luke's question.
So that's putting it into 2x plus 1.
Well, not yet, but yes, I'm going to put it into parentheses form. So my first one.
Oh, x minus 1.
Okay, my second one.
X plus 1.
My third one.
2.
No, not yet.
Oh,
X plus 1/2 plus I rad 23 over 2. And the last one.
X minus.
Nope,
Or plus.
still plus. Minus. Okay, so we finally get to Luke's question was, where did the 2x come from? Okay, well, we're good. What? Okay, we can't have fractions in our factors, right? Remember from before, if we had x plus half, if that was it, how did we rewrite that so that it didn't have a fraction in it anymore? We times it by 2, which created the factor 2x plus 1, which used whole numbers. So we want to do the same thing here. Okay, we can't leave our answer with fractions in the answer. So we're going to multiply this by 2, and that by 2, and this by 2. And everything within the parenthesis, 2, Okay, multiply all of those by 2 so that the yellow 2 cancels out that 2, the yellow 2 cancels that out, but not on the x, and then cancels out and cancels out. So that's where you end up with 2x plus 1, and then I rad 23 was left. And then 2x plus 1 minus I rad 23 was left. And then in the front, we still had our ones that were fine. X plus 1 and x minus 1, those were fine. Okay, does that answer your question, Luke? All right, Quentin, you feeling okay? You just kind of got 2/3 of the way through and you didn't get to the end. Annika, was that one of the ones you got right? No.
I didn't get it right,
So
so.
at what point could you pinpoint where it went sideways for you?
I think it was at like the end of quadratic. I just left it in the fraction and I didn't think to do anything else.
So you left it, can I circle it in yellow? You left it like here?
Yeah.
Okay.
And I saw the plus and minus and I just like, that was the fourth, so. Or like the fourth.
The third and fourth? Yeah. So just split them up. And so you were like 80% of the way. 85 maybe. Okay. Other ones from the homework. So yeah, open quiz tomorrow. So this homework you can use, your notes, whatever. Laura? Yeah, that's a great one. Okay, so we have the polynomial to start with. How far do you feel like you got? Okay, so let's check the synthetic. So this is 34. At least you knew you had to do synthetic division. So x to the 4th plus 13x squared. That's a good start. So let me just check what you had on your inside and outside. So what did you have on your outside? Okay, and what did you have on the inside? You skipped a 0. That may have been the problem. There's another 0. So you got the 0 for the cube, but then there's a 0 that comes after that as well. So that could have been it. That could be the culprit. Okay. Okay, so we drop the 1, and what comes next? 4i. Okay, what comes next?
4i.
And now we multiply the outside 4i by the lower 4i. I get 16i squared, but not really 16i squared. Okay, we get rid of the I squared, and we become negative 16, which gives me negative 3. Okay, then I multiply again. I get negative 12i, which drops down a negative 12i. Then I multiply, and I get negative 48i squared. But that I squared is going to cancel out the negative, which gives me 0. Okay. Then what? I heard it, but I can't tell who said it.
I think Rose had the right answer. She said, I don't know.
Okay.
Because it's
when you added 0 plus 4i and you got 4i and you multiplied it times 4i, how did you get the negative 16?
Because I got 16i squared, and I squared is negative 1.
Oh, okay.
Okay, what's next?
because 4i is 3i, you have to do the opposite.
Not the opposite, but the conjugate, okay? The conjugate. So, yes, we have to do it again with negative 4i. They come together in sets of 2. It's like girls going to the bathroom, right? They always have to go in pairs. So these conjugate always come in pairs. So the lovely thing about this is the second time through with synthetic division is everything cancels out. So you want to do it twice because the second time is going to get rid of so much junk that's hanging around there. So we drop the 1, and what do we carry through? Negative 4i. What happens?
It's 0.
We get 0, okay, which allows me to carry through a 0, and all I have to do is drop down a negative 3, which then I multiply by the negative 4i, and I get 12i, which cancels again, and I get 0, which gives me another 0, which gives me another 0. So the second time through is going to clear out a lot of the problems, which then allows you now at the end to reattach the variables back on. So 1x squared plus 0x minus 3 equals 0. And you want to solve that by an appropriate method. Quadratic formula, perhaps. Okay? So today is not the point of, we're going to assume that you've already solved that, and you're going to get plus or minus rad 3. So that gives you the total number of zeros that you need. Your zeros were the first 4i, the second conjugate 4i, and then rad 3, and then negative rad 3. So those are my 4 zeros. And then I create a corresponding factor for each 0. So x minus 4i, x plus 4i, x minus rad 3, x plus rad 3. Yeah?
I have a question. Like on tests and stuff, will you mark us down if we just do one factor with plus or minus?
Yes, they need to be separate. I should be able to count. Okay. So open quiz, very likely to be like something in like the 30s. 34 was a good example. 35, 36, something in that is very likely to be on the open quiz tomorrow. Okay. We've got time for a couple more. Lena?
Did you do 35?
35, the one that comes after that? Sure. Okay, what did you, we're just going to assume we're starting with synthetic, okay? All right, what did you have? Did you try that? Yeah, so what did you have on the outside and inside?
On the outside was 3 minus 2i, and then on the inside was 1, negative 6, 11, 12, and negative 20.
Okay, so this is,
And I was just confused and had it.
okay, so let's drop the 1. And then you weren't confused on the next multiplication, right? Okay, so 3 minus 2i, okay, and then when you combine that, what do you get? Negative 3 minus 2i, okay, because we combined the number parts together and then there was no imaginary parts to combine, so yeah, those combine, okay, and then did you get stuck?
Yeah.
All right, how do you multiply that outside number by that bottom number?
Do you do like the numbers here and the eyes together?
No. Yeah, you have to FOIL. Okay? You have to FOIL.
But the thing is, with the middle terms, will cancel out always, right?
Not always. No. So I'm just gonna scoot my work over, and I'm gonna do that over here. 3 minus 2i, and negative 3 minus 2i. And I'm gonna FOIL that. Okay? So what do I get? So yes, 3 times negative 3, that's negative 9, but what else do I get? Negative 6i.
Negative 6i, and then positive 6i, and then positive 4i squared.
Positive 4i squared. Okay, so my negative 6i, whoops, that was a positive 6i. You said positive, I just wrote it down wrong. Okay, those two cancel out, and then I want to change my I squared to be a negative 4, which means altogether I end up with negative 13. So I'm going to slide my work back over. Whoops. And I'm going to put negative 13 in, which drops down to a nice, easy negative 2. Now you should be able to distribute that, no problem, with the 3 minus 2i. So what will I get?
Negative 6 minus 2.
Careful. It's going to be plus 4i. Okay, and then again I drop down, I combine those two together, so that's going to give me 6, but then I have 4i. So now I'm going to scoot my work over again, and I'm going to have to FOIL one more time. 3 minus 2i with 6 plus 4i. So I'm going to scoot my work over.
Oh shoot, hold on.
Okay, 3 minus 2i, 6 plus 4i. So let's do that FOIL. All right, you start out with 18. What comes next?
Plus 12i.
Okay,
12i.
minus 12i.
Minus 8i squared.
8i squared. Okay, all right. So my middle I terms cancel out. I'm left with 18 plus 8, which is 26. So I'll go back and it's now 26, which makes 0. The first time through synthetic division with imaginary numbers is always the most challenging because there's a lot to keep straight. There's FOIL, there's distributing, there's just a lot to do. The second time through, if you can get 0 the first time through, and you haven't cheated your way, and you haven't tried to fudge it, and you haven't, you really actually got 0, it all worked out. The second time through is just going to be a breeze because everything will drop out. So are we ready for our second time? What are we going to use the second time we do synthetic division?
3 plus 2y.
Yep.
Negative 3 minus 2.
The 3 stays positive. Okay, when we do conjugates, you only change the imaginary part of a conjugate. So I'm going to drop the 1, and I'm going to multiply 1 times that really nice 3 plus 2i, and look what happens right away.
So
Okay? And it just makes, oh, you're like, whew, it's that sigh of relief. And then we multiply 0, and we get 0 again, which drops down to negative 2. And then I multiply that, and I get negative 6 minus 4i, which drops out to be, so it all worked. So the second time through, I promise, will always be, nice, whole, easy numbers. Okay, then we reattach our variables. So we're going to have x squared plus 0x minus 2. And you can solve that with whatever method you feel most comfortable. Star does not work, but quadratic formula or solving for a term. You end up with, when you're done with your work, plus or minus rad 2. So my zeros are the ones I started with, which were 3 minus 2i and 3 plus 2i, followed by square root 2 and negative square root 2. So each of those zeros will translate back into a factor. Now when you write a factor for 3 minus 2i, it still has to start with x. And then it will be minus 3 plus 2i. And then the next one, it still has to start with x. Minus 3 minus 2i. And your third factor still has to start with x. And your last factor has to start with x. So now you have a factor to match each 0.